Okay.
Does summarize a list? What's summarize?
Summarize is a function that will give you a data frame back. It gives you the data frame with this summarized data in there. Okay. So now st will have all these things, and if I say st max state, oh, not x, it'll tell me that. For some reason, it gives me negative infinity for one of these. Let's say tail st. The mean is NaN, which means, and we see why that is the case, because for ward 50, we have no information about state tax. Nobody has information in this data set. So when you try to do mean, or some of these functions with na.rm equals true, when everything's missing, you get some, I'll say strange results. But like think of it, mean, the mean is nothing. There are no records, so it tries to do like a 0 divided by a 0, so it says NaN. I don't know why the default to give you negative infinity for max or min, but that is why it's a good reason to keep track of, if you're doing na.rm, how many records actually went into the calculation. Because if it's 0, some weird stuff happens. Also, if it's only 1, you can't calculate, for example, a variance with only one value. Also, if you calculate with 2 values, you can still calculate a variance, but you shouldn't trust that measure really that well, right? Yeah. So it says, what's the maximum amount due in each ward? So max, right? All we did was change the measure we were doing the summary over rather than the mean.
If you took the group away, you just get a data frame with a single row.
Let's do it. Okay. Just one value over the whole thing. So one big group. Yeah.
Sorry, can you say again, what's the command for checking or for seeing what the groups are? Like if you want to like check if your data is still grouped.
So groups.
Groups.
So if you say groups on that. Yeah. I didn't know if there was a command called grouped. So after so whoops. Why is this not? That's strange. It should have grouped the data. So I believe, all right, so after you've done the summarization, I think it removes the groups. Because it's kind of, I think that's the case.
It's like a temporary.
Well, no, it's not temporary. It's just summarize ungroups it automatically.
Okay.
Right? But I'm saying like you can group it and then you can arrange like by, let's say, city tax. And if you did this, it will keep the groups.
Okay.
But I guess the thinking, I don't know exactly why that is, but I guess the thinking would be after you've already summarized it, it's only like one observation per thing. So I don't really know why that would be the case, why you would just automatically ungroup it. But yeah, it does. But if you want to explicitly ungroup something, remove any of the groups that happen there, ungroups the command you're looking for. All right. So somebody give me a way to get the 75th percentile. So we got max, we got mean, we got median.
You summarize the min 0.25.
What? Yep. So what do we want to call it? Let's say Q75 or what am I doing?
summarize, and then round two.
Okay, so let's keep us. Okay, so let's say I'm just gonna copy this. So okay, so what are we doing? So let's say Q75 equals. What are we setting it equal to be? Quantile, amount due, probs 0.75. So if you have missing values and you don't say any RM for like means, medians, all that fun stuff, they'll just give you NAs. Quantile's a little different. It will say no. It'll just error. It doesn't like that at all. Alternatively, what have we not done? At least so far. This one still has dollar signs. So I did it for city tax and state tax, but I never actually up in that code did it for amount due. So we have to just go back up here. And I don't believe we'll get to it, but you can do things like this. Where I defined on the fly, or in my code, just a simple function. So I'm saying this is a function that takes in something x. I call it x. It doesn't have to be x. And it says, what should it do? It should take x, replace dollar signs with nothing, and then it should make it numeric. So I'm just defining a short little function that I want to use in my script, so I don't have to keep writing these two commands over and over again. And if I do that, do, I can use that little shorthand command that I just defined. It's in no package, just in my script, to just say, okay, I don't want to copy and paste this over and over again. The general rule of thumb that I've been given is that if you copy and paste something over three times, you should make a function to do it. Right? 3 times is the limit. So copy and paste 3. If you're doing anything more than that, just define a little function that does that those sets of commands and just use that, and then use that. So here we did it. So I would, if I define this, I would replace all these with rec underscore dollar. So for replacing dollar, so then I don't have to rewrite the same thing. So now, like in my environment, there's a thing called rep dollar that's like a function. So it's totally not a data set, a vector, any of that kind of stuff. We'll probably not get to that, but I just wanted to show you that if you're doing something over and over and over and over and over again, you can make it a little bit more generic, and you don't have to keep copying and pasting over and over again. You can do something a little bit more strategic. Because copy and pasting leads to errors, like a bunch of them all the time. I'm sure you've never encountered that, though. Yeah. They lead to errors for me. I know that. Because, for example, you forget to change a variable, and then that's silently done. So now, like, you reran this command, for example, up here, and, like, I copied and pasted this, but I forgot to change state tax to amount due. Now you have a column that's amount due that actually is just a copy of state tax, for example, and now your whole analysis is flawed, right? Something like that. So 75th quantile, Q75, we use quantile for that. Probs, we have to give, for summarize, it has to return one thing. So we say probs equals 0.25. We say remove any missingness in there, and let's see. And now, somebody tell me how to sort this by the amount due. You're like, all right. It's just like, what's that? No, that's fine. No, that's fine. I'm just saying, like, this isn't that. I'm just saying, let's arrange this by Q75, and I want it to send. Okay, if I do this, What am I going to get at the top? The words with the lowest amount due. The lowest 75th quantile amount due. So if I want to do this decreasing, remember descending, we can run this command. Looks like Ward 4. Got some outstanding taxes still going on there. At least the 70th quantile is the highest. So again, I did max, city tax, state tax. Amount due would have been the same thing, just replace that variable in there. 75th percentile. All right, so let's work on 6, 7, and 8 for about 5 minutes. Yeah.
You might have said this already, but are you posting the additional code that you're typing in class?
Yes. It'll be called Scratch or Live Code or something like that. It'll be in the same row as data cleaning.
Okay, but, so is that live code, because the live code for day 1 and day 2 is gone now, and so is it just added to?
It's. What do you? Sorry, it's
Well,
called.
I just went to the website and they're not there anymore, it's just for day 3.
Oh. So those are older ones. So pretty much anything I've done should match the lab except for what I just did right here. Or the key. The key, I mean. Does that make sense?
Yeah,
Yeah.
just some of the other options that you're doing are nice.
Yeah, I'll post. Yeah.
You have to type it.
No, yeah. I will post that. Well, yeah, no. So So the thing that slows me down is questions. So ask those, and it will be slower. So I looked at the help file, and to do things from the right-hand side for string sub, you just put in negative indices. So the question you would ask, can you go from the left to the right? So you can if you say str sub -2 instead of a positive number, it says take it from the left or take it from the right. All right, so number 6, we said let's do some box plots. And so one of them was city tax by principal residence. So property, what is it, address? No. It's res code, yeah. Okay. So if we do that, we can use this formula syntax again. We do box plot city tax, plot it against res code. Should give us a box plot. Again, it's pretty ugly. Not very helpful because, again, there's some of these really, really, really large values. Yeah?
I got an error that said non-numeric argument to binary operator.
So take a look at your city tax. Just do a head of that column, and you'll probably still see that. Yep. So let's say we log 10 transform it. Take a look at it. Might look a little bit better. Still doesn't look great, but at least shows us that the median for a principal residence, the city tax is significantly higher and not a principal residence. So subset the data to only retain those houses that are principal residences, which commands subsets rows, filter or select. Filter. So we can say tax, we can filter it in there, and then we can say res code equals principal residence. Right? It tells us there are 114,000 observations. It says principal residence. Now, we didn't do any string cleaning, that kind of stuff. Before we did that, we should have probably done a simple table or unique tax res code, just to make sure. It's just those two. There weren't any space issues, anything like that. If we wanted to make sure that the res code didn't have any extra spaces, we could say str trim. Right? If there was white space in the front or the back, so that when we did some string matching. We could also do some fun stuff where we say, okay, str detect not. Oop. So what this will do is it'll filter the rows that don't have the phrase not in there. Right? So it's saying find in res code the word not and then negate that to turn the trues to falses. That'll also give us the same thing. This is the exact same thing. This is a lot more robust, especially if we have like 10 or 20 different things kind of in them as categories, and we want to just say like throw this one out, or we want to subset based on some other variable or something in the variable name of the character. So let's call these print. Okay.
So if you're looking for specific common misspellings or something, you could do, and you know what they are.
Mm-hmm.
Could you do like a list of ways, like say a district is commonly spelled 5 different ways.
Yep.
Could you list more than one?
So it's just a true thing. So you could say or str detect res code, right? District, something like that. So you could do or over and over again. And I don't know if you caught this. I was answering your question about from the right or the left for string subs. Okay. So if you use negative subscripting, you can go from the right. All right. What was I going to say? I misspoke earlier. When you use fixed, ignore case is not on by default. So if I looked at the help for fixed, and it says ignore case equals false by default. So if you set that to be true, then it will ignore the case. By default, it's not. It does exact string matching, case sensitivity. Let's describe the distribution of property taxes of these residences. So let's just look at these. Let's use hits. Let's just do plot density. And let's do print. I'm going to use city tax here. X contains missing values. Density doesn't like that. It's ugly. Okay. So again, pretty right-tailed. Right? So there's some properties in the city that pay a whole heap of city tax that are still principal residences. I forget what it is. It might be one of the mansions or something. I don't know. We can find it, right? This is $60,000, right? So I can say filter print city tax is greater than 60,000. There should only be like one record. Maybe two. And let's just select address, property address. Get somewhere on Russell Street. 702 Westlake Avenue and 801 Key Highway. I don't know. They're expensive. Okay. Let's plot your lot size versus city tax. We didn't do the lot size cleaning. This was this is the fun ways that it describes lot sizes. So this is what I was saying before. 13-8 is like 13.8. They also use points in here, 0.026 acres. They use square feet. They use, again, cubic feet at times. So lot size is kind of one of the best examples of how wrong data can go with respect to standardization. We're not going to work on that, but pretty much at the end of the day, this was going to show you that some lot sizes were, the bigger the lot size, generally the more taxes you had. So I say we move on to part 4, because we that pretty much is where we're going to get into a little bit more of the string manipulation and take like 15 minutes on that. We're probably not going to cover each one of them. But it will get you using fixed and that kind of stuff. So we're going to spend a little bit longer than I was anticipating on this, but I think strings are vitally important to kind of doing data cleaning. All right, so part 4 we're going to do, let's do 10 to 13, and we'll take like 10 minutes to do that. So this is some new data, not necessarily the tax data set anymore. Oh, non-binary arguments in unary operator. That means it's trying to do some sort of calculation on a character, like a numeric calculation. So what I'm saying is, if you try to do that, that usually, so if you go back, so 1, you have to split the order, so it's y tilde x. Right, so let's put these around. So syntax should be fine. So it goes y tilde x. Alright, now I know everyone's name. Now I can follow people. So it's not just going to be dead silence anymore. It's going to be it's either going to be during the headlights and dead silence, or not. Or we're going to walk it through. We're going to talk it through. The R therapy session. Okay. So let's make an object. So everybody can read in the data fine, I imagine, right? So read.csv. Let's make an object called health.sal that using the salaries data set with the only agencies, those with fire of any or any forms, if any, in the name. And remember, fix, ignore equals true. Ignore the case. All right. So health.sal. Anybody get this? Yes? No? Maybe so? We got like a okay.
I have problems with ignore case.
Problem with ignore case. Okay, so the job title. Let's see, head. Let's just look at the data really quickly. So job title, hire date, all that kind of stuff. Let's use view so we can actually look at some of this stuff. Okay, we got job titles, agencies, fire department. So let's use the agency. Again, look at these salaries, dollar signs in them. You know, government data. It's got all these things you got to clean up. All right, we got to say health.sal equals sal. We're going to pipe in. We're going to do some filtering, right? str detect. Remember, filter and str detect go well together. What are we going to do? We're going to use agency. And what do we want to look for? We want to look for fire. Right? If I do this, what do I get? Just like this. Nothing. Table with 0 rows. Right? So I can say fixed. Ignore case. Nope. Ignore case. True. View health.sal. So we're going to bring this up. So we see fire department over and over and over again. I think that's the only agency. But again, we could have looked for just fire, but if we just look for an exact string fire department, we could find that as well. But if we were trying to use equals equals or that kind of stuff, these are all different agency IDs on them. So again, filter, str detect. So we said, okay, pipe this data set in there. We use the agency variable. We're going to look for fire. We don't want to do anything special. So we could use regex. It doesn't matter. But the argument we put in, it's got to be in the fire command. Ignore case equals true. It says look for fire. I don't care how you find it.
So you have to use fixed if you're using ignore case.
Correct. All right. So let's do the same thing for trans. Because there's multiple. And let's do just a table just to confirm. If I say health.sal agency, it's going to give us a whole bunch of different fire departments, and we can give a breakdown of that. But this is all the fire department data. So we can say trans. Let's do the same thing. Let's say it contains trans. Let's look at the agencies for that. Trans, highways, that kind of stuff. If we wanted to just if we wanted to just look for trans, we knew we wanted that case. We didn't have to put all this stuff there. Again, this will find the ignore case equals true will have found the word trans in any different way, shape, or form. Also, we could have done something fun like this to say I wanted that to be the start of the string, right? This little caret will be the regular expression that does that. So there's all different type of transportation agencies going on here, and so we subset based on that. So what is /r the professions of people who have abra in their name? So case should be ignored. So again, let's call this abra. We're going to do the same operation here, but we're going to say fixed abra ignore case equals true, but we want it to be name. First column is name. Oh, unexpected symbol. Need to end that. So if you see a plus sign at the end of your line, rather than a greater than sign, which means the prompt, this means you have entered something and R expects more. So you usually have forgotten to close a parentheses or to close a quote. You can hit escape to kill it, or you can actually figure out what you need to close. Abra. So we got Abraham as last name, Abraham as a first name. So we got a lot of eyebrows. All right, we got 12 of them. So let's find the professions. Let's do table, Abra, job title. Let's see what they do. So we got accountants, auditors, collections representative, general counsel, laborers, police officers, trainees. Yeah. Okay. What does the distribution of annual salaries look like? Use a histogram with 20 breaks. What is the IQR? We're going to use Quantile for that. We need to convert it to a numeric, but again, we need to take dollar signs out of there. We've done that about 15 times already today. So I'm just going to copy and paste some code from up here. Where's that fun little thing? Function, rep dollar. I'm going to use this command. We don't have to redefine the function. I'm just doing that down here so we can, again, see what it is. And in here, we're not doing tax. What did we want? We want the salary, right? What's it? Annual salary is the variable we want. Just going to do that change. Do a histogram. Oh, now we can do annual salary. Breaks, let's say, is 20. I don't know what I said in that code. So, majority in this data set are making anywhere between $35,000 to $90,000, probably the majority of the data. There are some people way out on the tails making over $200,000 in this data set for the Baltimore survey. Okay, we have some annual salaries that are really, really, really low, so those people are either part-time, hourly, or the data is probably coded in a very strange way. So, but that's one way you kind of look at your data, do a little cut of it. You got to strip off the dollar signs, and then you're ready to go with histogram. We said 20 breaks. We can make it 100 breaks, but it just zooms in on the data a little bit more, depending on what kind of looks the best. There is no exact rule to say how many breaks. So what is the package we use for dates? Lubridate. So one thing you should note, if you start typing library and don't type it right like I do all the time, it won't turn a fun color until you put it correctly. So if you see something, like if I just did this, it says, I don't know the function library, right? Usually if the color hasn't changed, something's gone wrong. If you spell function wrong, for example, that won't give you a function. Okay, so let's convert higher date to a date, right? So we can use mutate again. There you go. What do you got? What do you got for making me a date? So what do you guess to be the format? What do you think? Month, day, year, day, month, year. Month, day, year, right? There's no 25th month, so this has got to be the month, and we know it's a 4-digit year. We're going to say, we're going to convert higher date, we're going to replace it, month, day, year, higher date. Also, you know you're in Baltimore City. Good guess is month, day, year if you're in the US, but again, you should not be guessing with your data. So, let's use annual salary and higher date. Let's do, what are we doing? Boxplot? Again, these are boring yet effective plots. We will spice them up probably tomorrow after we talk about some manipulating data today. I don't know why my box plots take forever. Whoa. So, it's not very helpful because I did box plot, which made no sense. So you probably want to do a scatter plot. To see that. Ooh, not so great either. Tomorrow, we'll show you a fun way. X is hire date, Y equals annual salary. We want to put points. Maybe a little bit of smoother there. Okay. What? Why did it run everything? I'm missing in parentheses. So when it's done, oh, there it is. So it's saying this is the when you were hired, what's kind of your annual salary. Doesn't seem to be a huge strong relationship. Does a little smoothing. We can do some alpha blending, some other fun stuff tomorrow to make these plots look fun. There's other things called Geometries. Again, it's doing a smoother, do a little thing like that. It's not a scatter plot. It's doing kind of like a little density to say like where's the data kind of sitting, because if you do a lot of data plotting with points, there's a lot of over plotting usually in there. So it's saying this is kind of like a somewhat of a histogram, like a two-dimensional histogram of sorts, but the height of the thing is mapped to a color. Okay. So let's see. Let's skip 15. It's just subsetting the data. But we have to use it again. No, we have to create a variable. Okay. Sal, we're going to mutate. And now, I'm going to talk about what this does. Okay. Bless you. All right, so what is this going to do? So what is this regular expression? So we're mutating the data, we're creating a thing called department. We're extracting from the agency this weird thing. So dot star means anything can come up. Anything there, but I still want to match that. So anything. Right? So dot means any character, star means repeat that 0 many times. So dot star means match literally anything for as many letters you get to. And then we're looking for ment or ice. Right? So for department or office. That's what we're looking for. We group this together with parentheses. We put a pipe as in this or that and in the parentheses. This is an example of a regular expression. This will only detect things and only give those things back into the department variable where the agency has either the 4 letters ment, all lowercase, or the 3 letters ice. And it will extract everything up to that. So let me show you this. So let's select Sal Dept Agency. And then obviously not let me see everything. Okay. So what did this do? It says match that, ment or ice, and then it didn't say the rest of it, so it says all the rest of it you can throw away. So what did it extract? It said, okay, health department, these agency codes. You're saying, I don't care about these. I don't need these. I just want, whether it says department or office. Right? When I actually subset the data before, when it was the fire department or the police department or whatever, it didn't have any NAs. But here, for example, it says, it sees office, it sees ment, so it puts these in there. STR extract sees them, puts them in this new variable. This doesn't have ment or ice. This one's called info technology. So it says, I never found these strings, missing. I never see that string, missing. Department, right? But again, it doesn't have 005, 020 in there. It says match only up to this point. Everything else can go away. So we're not going to get too detailed into regular expressions. They are a thing onto themselves. But note that learning some very basic ones or looking online to say, like, how do you match like 3 digits or something like that will be very helpful and will get you a long way. All right, let's get into manipulating some data, even more so than we have. So I don't know, I'm not the biggest fan of the way we name these things because we've been manipulating data the whole time. But when I say manipulating data, I mean reshaping. So we're going to be talking reshaping data from wide to long or long to wide. We're going to talk about merging data and format variation by grouping variable, even though we did the last one a whole bunch of times. Probably going to breeze over a lot of that really quickly. So new package, tidy up. Okay, it's for tidying up your data. So there is a really good cheat sheet here for wrangling and tidying up your data. It gives you nice visual displays on what things are doing. So we're going to talk about reshaping data. We're going to talk about the spread command and the gather command, and it shows you and color codes things to show you what happens when you execute these functions. And moreover, it shows you when you do joins. Left join, right join, inner join, full join, semi-join, anti-join. Okay. So again, if you come from a SQL environment, this makes sense. Unions, set differences, intersections, but the joins are the ones we're really going to be talking about. So I don't know all of these functions, but I would say looking over this cheat sheet for about 20 minutes will get you, a really, really long way with respect to data manipulation. Okay, we've already gone over selecting and all that kind of stuff, but it's pretty much everything kind of dplyr in a nutshell, and tidying and gathering and spreading your data. So what is wide or long data? So the way I think it's most commonly described is whether it's multiple rows per observation or not. I like to think of a data set as wide or long with respect to a variable. So a data set can be wide and long at the same time, depending on what variable you're referring to. So, for example, I think the common way everybody thinks, at least in public health, you have an ID, 1 row per ID, you have multiple visit data, and you have like visit 1, visit 2, visit 3 as a column. That's what they think of as wide, and this would be long, visit 1, 2, 3, with the value in there. Now, almost all the functions that we're going to use for plotting and stuff like that want things to be long. Okay? There are a lot of reasons for that. You can do filtering and all that kind of stuff really easily here. Otherwise, you have to start mapping out a lot of variables in there, specifying visit 1, visit 2, visit 3. Whereas this, you just specify visit, and then you can filter based on which visits you want. That kind of stuff. Okay, that's what I said. With respect. So some of the data we'll be talking about, like the circulator data we talked about before. We had a different column for the purple line, the green line, the blue line. Whatever, we don't have a blue line. Purple line, orange line, green line. And we had multiple observations per day. So it was long for each one of those lines, but it was wide with respect to the line. Right? So, again, in the examples we're going to give, this is the exact data we were talking about. So it's multiple measurements across the days, right? But orange boarding, A lighting for a specific combination of the date. It only had one observation, but you had multiple observations on that day. And they're all in one line. All right, so what this data has, the day, the date, which again, you see as a character when you read it default in. So orange line, orange boarding, orange A lightings, orange average. So people getting on, people getting off, they are not exactly the same. It takes pretty much the average of the two to get a somewhat accurate count of how many people rode the bus that day. So we got that for purple, green, the banner, and we have daily ridership, some overall measure. So we're going to do the date thing that we just talked about. We're saying, is there any missing values? Are any of them equal to nothing? Right? Again, when you use read_CSV, empty strings are converted to NAs, so that should have been picked up here. But sometimes, there might be spaces or something like that. So again, we're going to use MDY, right? We're going to use these lubricate functions, and now we're going to say, are any of them NAs? We didn't necessarily do this interactively to see if there was a warning. So this is a programmatic way to say, like, hey, you didn't have any missing dates before. Are there any missing dates now after we did some conversion? Because sometimes you do have to do mix and match conversions, so you have to convert the data, and then you have to use, for example, an if-else to say, is it still missing? Maybe we have to use a different format than MDY. Okay? Okay? Now the data is in a date format, so we can do some fun plotting a little bit later. So now, the reshape command in R exists. Don't use it. It's a bad function. It tries to do too many things at once. It tries to do a general function that allows you to reshape the data wide to long or long to wide at the same time. Similarly in Stata, it is not always that easy to reshape data. You know, sometimes you have to put the exact variable name when you're going from one direction. Sometimes you can use wildcards and stuff like that. If you're going from like wide to long, you can put wildcards and everything's fine. And there's IJ things. And yeah, no. All right, we're not going to use the reshape command. It exists. We're not going to use it. So tidyr. This is the package that we're going to use to tidy our data up, and that usually is going to be reshaping. Also, we're going to talk about these two functions, separate and unite. They allow you to do simple string manipulations where, for example, if you have something where it's like ID dash site dash visit, and if you want to separate that into 3 columns, separate can do that for you. You say separate, dash is the separator, and now you have 3 columns where you separated that thing out. You didn't have to do explicit string manipulations, all that kind of stuff. Didn't have to work with string split. Didn't have to work with lists. It does what you needed to do. Unite is the complete opposite. You have 3 columns. You want to paste them together with some separator. Joins them together. But gather and spread. So you gather up columns into variables. So you go from wide to long, and spread, you spread them out. So you go from long to wide. So, okay, so we're going to put columns into rows. So the syntax for gather is, so it's kind of like the IJ stuff in Stata. You have to say, what is the new variable you want to give? And that being the variable that contains the names of the columns. All right, so before we had purple lightings, A linings, orange boardings, that kind of stuff. They were the column names before. So key is saying, when you want those column names, when you want to specify and bring them down, what do you want that column to be called? And then when you actually take the data, you take the real data that was in there, what do you want that column to be called? So here, I called that column var, and the value from those columns, it's called number. And then you say, so you say data set, what are the 2 new columns that you're going to create? And then you tell it which columns to gather up. And the syntax for that is the exact same types of syntax you use for select. So again, you can either tell it which columns you want to gather up explicitly, or you can tell it which columns you don't want to gather up. In this instance, I said I don't want to gather day, date, or daily. Which means it's going to do all the other ones and gather them up. Okay? So day, date, and daily stay exactly as they are. The other ones get reshaped down. So now they were column headers, but now this is a variable, and this is the value that was in them. We do a little table. Sorry, I showed one way where we gathered the data by dropping certain variables that we didn't want to gather up. This way, it's the same exact thing. It's just more explicit, saying, I want to gather these columns. Any column that starts with orange, any column that starts with purple, any column that starts with green, anything that starts with banner. So again, you can still use those useful functions that you did use in select. It starts with, ends with, one of, matches, all that kind of stuff. You can use the colon operator like HV000 colon HV005 or whatever. Again, that's fine. If your data is highly structured, it will take those variables and gather them up. But if those variables are reordered, when you read it back in, you're going to get something different, just like you would in Stata. You get something different. All right. Does that make sense? So you gather, data set, 2 new columns. What are the things you want to gather up? So again, when we do the table, we see there are 1,146 observations. So that's how many days there were actually observed in this data. And we have records now for each one of the variables that we gathered up. Okay? So, let me see how many slides do we get. Yeah, I think this is good. It's a pretty short, I think, part 1. So let's go to the lab for manipulating data. Let's see. Where did R go? Ah, it's in there.
Yeah.
Ah, forgot to take out the key. Well, it's no fun. Everything's in there. Oh, shucks. All right. Uploaded the wrong file. So really briefly, let's just look at wide what we actually read in. So for each one of the streets, it is the mean bike lane length for the different types of bike lanes, right? So even ones for NAs. So it's saying for like Alisana Street, there's a Sharrow lane with an average length of 250. You know, Bank Street, there's one at 165. It's also got a signed route that's 146, feet. So that's the data we have in, and we don't want the data necessarily to be like this. We want to have it to be similar to the data we had, talked about the other day or showed the other day. We don't want it like this. We want it reshaped. So if we say, all right, let's say the key is the lane type, the value is the new column we're going to have, which actually has numerical data in there. And I want to gather every single column but name. If we run that, let's view what we get. Now, note, we have a whole bunch of missing values here because it didn't do anything. It didn't drop the missings. It said, all right, you're just going to reshape it. Now, if we want to drop the missing data, how could we do that?
You could select the rows with not missing data.
With which function? Filter. Let's do that. So let's say filter. How do you say not missing?
NARN equals true, not, or true.
So it's a not,
Right.
but it's not NA.RM. It's is.NA.
Oh, right.
It is confusing. Right, so let's say long. Now we have data where only data exists. So only data exists for these lengths. So now, for example, some of them it didn't have a name, but it had a bike boulevard. Right, Pratt Street. So we condense the data now, remove those missing values that are no longer relevant. So, for example, if you had visit 1, visit 2, visit 3, visit 4, visit 5, visit 6, all that kind of stuff, we could have reshaped it that way. All right. Now, great. We did some reshaping. Now, I'm going to do a little bit of replacing. So although purple average, this kind of stuff is explicit, I know what they are, I want them separated by something. Right? I'm fine with boardings, A-lightings, all that kind of stuff. So I'm going to separate them. In this case, I just chose a period. Probably a better idea would be to use an underscore. And I'll show why that's a better idea in a minute. So now we have banner, A-lightings, banner, average, blah, 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 blah. Right? So I just said, replace board with a period board, replace A-light with a period A-light, replace average with dot average. So again, we mutated the data, so we're reassigning a variable, var, and we piped it into string replace, and we piped it into these two. So that's why str functions are very conducive to piping, because you say do this, then do this, do this, right? We could have done this in 3 different steps where we reassign var every time in the mutate command. Whatever makes the most sense to you is the way to go. But does this make sense? We're just changing this. We want a period to separate them two. Now if we do a table, we see that they're separated by periods. Why do we care to do that? Because the separate command will allow you to separate a variable, in this case var, into line and type. So we want the color of the line, whether the banner, blue, or banner, purple, orange, or green, and what they are. Is it getting on, getting off, or the average of the two? So separate will do that for us. So we can give it a separator. In this case, using a period is not that smart because periods are special, and what separate does is it treats these things as a regular expression. I do not know if you can use fixed in this, but we're going to find out in a minute. I'm going to read in this data. Oh, I'm just going to go to manipulating. Okay. Okay, just clear all that out. All right. So, if I say fixed, too many values. Oops. Now I've angered it. Okay, so you can't use fixed. So fixed is specifically for string R functions. But if you would like, if you run into this problem, and this is why we give this example, underscore would have been easier. We would have just said underscore because it's not special in regular expression. If you do run into this problem, you're saying, I really want to split on exactly a period. If you put it in square brackets, that's saying to in a regular expression, just treat this as fixed. Okay? So string R gives you really nice functionality, gives you nice functions that say like, hey, this is a fixed expression, don't do any fancy stuff. But in some other functions, you still have to know if it's using a regular expression, you have to encapsulate it in these brackets. But let's look at also the help file for separate. So we have a data set, which column you want, and the columns you want to break it into, and the separator. If it's a character, it's interpreted as a regular expression. Right? So we have to do this. Where did we go? Back over. All right. Now we separated them out. So more or less, it's split it. Right, so let's go back one more. So the data. var. We changed it into periods. But now, split it up, and it removed that variable. Okay? So it says var, it split it on the periods. Now we have one one variable for that, another variable for that, and var, the variable itself, is removed. Okay? So separate allows you to do some simple string stuff to get things out of there. So now we have purple, green banner lines, and bordings and lanes and average. Now we have them as two separate variables. Now we can do some other manipulations. Or we can do, for example, what we're going to do is take the bordings, a lightings, and averages and make that three separate columns. We're going to spread that back out. So we're going to keep it to be orange, purple, green, and banner, but the different types, the different measurements are going to be spread back out into the columns. I'll show you that in the next slide. So, opposite of separate, unite. Paste stuff together. And it's just pasting things so it doesn't do any expression matching or anything like that. So you say, all right, take the data. I want to unite. I want to make a new column. This time it's called var. And I want to take line and type, and I want to separate them by periods, and it gives you pretty much the exact same thing back. So unite is the opposite of separate. Separate makes multiple columns from one. Unite takes multiple columns, pastes them together, and makes one column and removes the rest. We could have also used paste 0 if you want to keep both columns. A lot of times you don't want to. A lot of times you do want to do the separation. And then you want to remove the columns that you didn't need anymore. Also, we could have used string splitting, but again, this is really specific for data frames, but it's a lot of times what you want to do with a data set, and you don't have to work with lists or any of that other crap. All right. Alternatively, we could have changed the column names first and then reshaped it, but whatever. So, part 2 is going to do some separating. So let's go to that lab. Again, act like you don't have the answer. Like, All right, so we read in the crash in the road data set, right? So these are crashes over the years and specific roads and how long they are. So we want to use string replace to add any hyphens, to replace any hyphens with a space, and then table the road variable. So if we look at the original data, we see it's Interstate 65, Interstate 275, and US dash road. So totally fine, but it's not so great. If we're trying to split these things up, maybe we care about the numbers or something like that. So we just said replace everything, every hyphen with a space. So now US 40 and US 36 no longer have hyphens there. So how many observations are in each data set? If we just say n row road, we spell road right. So there's 110 crashes, only 5 roads in there. That's because in here it's just pretty much the road, which district it's in, and how long the road is. And then we got the data. So now all the hyphens were replaced with spaces. So now let's separate that column out. So we say crash 2. We're going to throw it in the separate command. The column that we care about is road. We didn't have to put quotes around it. You can put quotes around it. Totally fine. Into which 2 columns do you want to create? You have to use this as a character vector. You have to say type and number. You don't have to say type and number, but you have to, whatever columns you're trying to make, they have to be characters. Right? And then the separator, in this case, you can just put, I would say this is probably the easiest syntax. Separator is just a space. It'll try to guess at a separator if you don't give it anything like that. But you say, okay, crash 3. You don't have to do, sorry about that, crash 2. Oops, that's supposed to be crash 2. I replaced it. Just gonna run all that again. So it didn't matter if you put these brackets in there. It's fine if you do. It's just kind of overkill. You only need them when you're using special characters. In this case, you just put a space. And now if we look at crash 2, we see that now the type of the road is in a column where either it's US or interstate, so we know if it's an interstate road or a US road, and the number associated with it. So now we can filter and say, all the ones that equal interstate, or interstate and the number is greater than, 70 or something like that. So let's do the opposite of that effect. Let's create a new variable called road hyphen using the unite function. Unite the type and number columns together using a hyphen. So again, we're piping into unite versus separate. We want to say what is the column that we want to create, right? That has to be in quotes. What are the things we want to unite together? Type and number. The order here matters. Right? It's going to paste things together in the order in which you give it. And now if we do table crash 2 road, right? It gives us things back, but now it's interstate dash, interstate dash, interstate dash, US dash, versus if you, in the original data they were spaces. So again, just doing the simple reverse operation, and which and how many years were the data collected. If we just do table crash here, right? Another thing saying do some tables, do some tabulations. We could have done group bys or something like that, but tables is a pretty simple command on its own. So unite, separate, pretty much opposites of each other, but a lot of times that's what you want to do. A lot of times the string manipulations you want to do are simple stuff where you want to split things out, you want to put things back together. And that's a good way to do it, rather than, and you still have paste at your disposal. Right? If you want to do paste certain things with different separators, or do some other string manipulations, you have it. All right, so tall data to wide data, or long to wide, tall to fat. That's what some people actually say. People describe data in strange ways. So the opposite of gather is you spread things out. So think of seeds in a field, you gather them. The opposite of, I guess, would be to spread them out. So now we have data, and we're going to filter the data where it's not missing the date. Again, this is overkill because we looked at the data, we saw that no date was missing. But again, sometimes we just want to be explicit, we want to make sure, and then we spread the data. This is the data set, wide. So again, we made a new data set wide, where we just filtered it. We spread the data wide, and we want to spread type, number, and the two arguments for spread, let's look them up. It's the column that you want to spread out, and in this case it was called type. Let's go back. What was type? What was type? Type is boardings, A-lightings, whatever. And then what is the column of information that you want to spread across them? What is the actual data? So in this case it was the columns which actually had the numeric information in there. We spread those out now. So now we have multiple observations per day still, like we did in the long data set for the different lines, but now we have them separated by the numbers are correctly separated, right? Those numbers, although they kind of mean somewhat similar things, when they're in this form, kind of aren't appropriate, because this line doesn't necessarily mean the same thing as the next line if it's boardings and A-lightings. In this case, it still means people, but for the most part, this is probably one of the most appropriate ways to kind of have the data, right? So now we can do fun things where we plot the A-lightings across different lines, all that kind of stuff. So now spread is the opposite of gather. So let's do some spreading in part 3. All right, so we're reading in the bike data set, right? We're filtering on any rows that have missing value in type and reassigning it to bike or name, or missing name. So again, just filtering operation. We want both not missing type or name, so we can just put commas separating them, or we could put and in here. It's okay. Select only type, length, and name. Again, we're using the select command. Summarize the group, the data by the grouping name, and take the sum of the length. Call this data set sub. Right. So if we look at this, for every single street, we now have every single street in separate type. So we've just collapsed them together to say what's the total number of what's the total length of bike lanes you have there, right? So that we have one record for that. And now that we have the data like that, let's say we spread out the data. We're going to spread out type. So type is going to now go in our columns, and the value we want to spread out is the length. So let's view wide. So not surprisingly, from when we started this exercise, this is the data set we actually began with. So it wasn't the mean, technically, it was the sum over all the data. So pretty much we had this in a column, or in a row as a variable, and we wanted to spread it out as columns, and this is the data we had. So we just use spread again, told the data which column we wanted to spread out into, or which variable we wanted to spread out in the columns, and then what do we want to fill that data with, which column, and that was the length. Okay. I don't know off the top of my head, or I don't know the recommendation, whether you want to do a whole bunch of variables at one time. The reshape command can do that. I believe if you're reshaping, like, visit 1, visit 2, visit 3, visit 4, like something 1, something 2, something 3, something 4, like, blood pressure, then heart rate, and then all that kind of stuff. I believe the recommendation would be to reshape them individually and then merge them together. I'm not 100% sure if that is the overall recommendation, but spread and gather can do that. You could have gathered them all up where it's like heart rate 1, blood pressure 1, that kind of stuff. And that's all fine and good when the type of the variable is all like numerics, for example. But if you want to do that where some things are character and some things numeric, that's totally fine to do. But when you spread it back out into its respective columns, then you have to make sure you convert characters back to numerics. Because if you gather anything that has characters in it, remember, that column's all going to be the same type, so it's going to be character. Does that make sense?
But as long as the data are all numeric, then you're okay.
Yeah, it won't convert coerce to anything else. Or if it's all character, you're fine anyway. Yeah. All right, so we're going to get into merging and joining. Okay, so we're going to use a very simple data set here. So a baseline data set where IDs 1 to 10, just give it some ages, right? So you got ID 1 to 10, the age for that. You got all 10 IDs in there. We have some visit data where we have IDs 1 to 8 for 3 separate visits. We gave it some random outcome. Note, 9 and 10 were lost to follow-up. They are not in this data set. Okay? 9 and 10 are not in the follow-up data set. So this cheat sheet that we talked about in the beginning is really good. If you do question mark join, it talks about all the different types of joins. Inner join will do, for stated people, merge equals 3. Anything where they both match up on the ID variables. It'll keep only that. Full join will keep everything from X and Y. So it says inner join X, Y, right? So inner join says only where we have keys, and I'll call them keys because they're not necessarily unique ID variables that match up in X and Y. We'll keep those. Everything else that doesn't match up, we're going to delete. Full join says if you're in the data set X, if you're in the data set Y, even if you don't match up, we're going to keep you. Left join and right join, it matters the order of the arguments. So left join says keep everything in X. merge all the stuff in y into x, but if you don't merge, if something from y doesn't merge with x, get rid of it, because x is the first thing and we're merging onto the left. Right join exists. I don't know why I tend to think of left joining in my mind. I guess this is maybe a remnant of the SATA thing where you have a data set and then you have a using data set come in. But the idea is right join is the same operation. It's just saying now if you put x and y, keep everything in y, all the rows of y, and even if they're not merged with x. Right? So it's the same operation as left join, just the order of the the order of the arguments are different.
So in Stata, usually you do the merge and then you sort of look at what's merged and what hasn't merged on both sides, right? Like from the using and the
Correct.
original data set, and then you can kind of drop things. Is there a way to do that in R?
So I'm not going to show you if there's anti-join.
Okay.
Anti-join is order dependent as well. Anti-join x, y, I forget, I believe it's the things of y that didn't join with x. And then anti-join, if you flip the arguments, it's the things of x that didn't join with y. Right? So there is an anti-join. So that is, I think, the number one thing people come here to say that they don't have a variable that indicates whether things are merged or not. You can always create a new column that's like y, a column called x, a column called y, and then do a crosstab of the two after you've merged them, and then trash them later. That is essentially all underscore merge is.
Or if they're the same name, because before we had Haven, we were doing like merging the labels and the values for DHS data.
Mhm.
It gives like a dot X or something.
So so by default, these will do the intersection of the column names. So if X has a column name age, Y has a column name age, they have to be exactly the same case, right? Then it'll say, and if you don't put any arguments to say, what do you want to merge by? It'll say, oh, I see an age over here, I see an age over here, we're going to merge them. We're going to merge on that. So it'll be like ID, yep, age, yep, whatever else is in there, it's going to say, that's your unique identifier. Now, if you do have age here and age here, but you explicitly say, I just want to merge on ID, they will be given suffixes. So whatever's in X, by default, will say age.x. Whatever's in Y will be age.y. Okay? So IJ is the inner join of base and visits. So we see at the end of this, 9 and 10, the IDs are not there because IDs 9 and 10 were not in the follow-up data. So the inner join only is the intersection of the two data sets. Okay? Left join, base and visits, saying, hey, if you're in the baseline data, keep you no matter what, no matter if you merge or not. That's why 9 and 10 are in there, but their visit data is just missing. It will not do anything like, it won't do anything crazy, like try to put like one, because everybody has 3 visits here, it won't like make 3 records or anything like that. Okay. Right join, it says, hey, if you're in visits, stay. If you're not, or if you're in visits, stay, and anything that merges with visits, you're great. Everything else you can throw away. That's why, again, 9 and 10 are not here. Note, though, the order gets a little bit different. So the joins are, so if we flip the arguments, right? So this, I did a left join of base and visits, right? In Stata, base was my original data set. Visits was my using data set. If I flip the arguments and then did a right join, it's the exact same operation. The only big difference is twofold. The order of the columns is different. So remember, this right join, ID, visit, outcome, age. ID, age, visit, outcome. They're different because of the way it's done. Because the right join, right, it essentially, it's just reordered to the columns because of the way it's merging the things together. Also, the way the rows are sorted are different. So I said identical equals true after some rearranging. All I did was I reordered the columns, reordered the rows to be the same ordering, and then identical says, yep, they're exactly the same. It's the same operation. So left and right merging are the exact same thing. I don't know where that goes. It's just the order is different.
Sorry if I missed this, but do you have to specify like many to one, one to many?
Nope. So by default, we'll say join by ID. We'll do the intersection. Lastly, I'll come to this full join. Everything in X, everything in Y. So if we don't specify, if we do want to specify them together, if we do want to specify what we're joining by, the argument is by, and you put in a character string of the column names that you want to join by. So in this case, it would be ID, but you could do a whole bunch of things, and you see at the end here suffix. So if you have, like we said before, two columns in X and Y, both called age, but you only merged on ID, you will have age something, and in this case by default, age.x, age.y. If you wanted to make them underscores, if you wanted to make it age.baseline, age.followup, something like that. I don't know what a semi-join is, and I never use it, but anti-join will give you the not joins, but again, it is order specific, just like left and right join are. So if you look in some of these help files, anti-join returns all the rows of X where there are not matching values in Y, but it only keeps columns of X, right? So it's not like these are the, because it doesn't make sense, right? There's no matching values of Y. Why would you put just missing values all over the place, right? Because it's not in there. And if you flipped the X and Y, then you would see, all the values of Y that aren't in X and all that kind of stuff. So although we show you for kind of simplicity's sake and for teaching, I personally would always specify what you're merging by using the by. So again, in Stata, everything's a full join, right? So it's like merge, by is your variable names, using, visits is in this case the using, and then you say underscore merge equals 3, that's an inner join. If you don't care about underscore merge, that's a full join. Left and right joins are just, sometimes you want to say that's just like underscore merge equals 1 or 2, depending on how you're doing it. So we talk about sometimes there are some weird things in your data. There is a function called duplicated, which gives you an indication of if a record or something is duplicated. So if you say duplicated, for example, on 1 to 5, none of them are duplicated. They all come up false. It doesn't do exactly what you think, though. If you say 1 to 5 and we add a 1 to the end, duplicated says false for everything except the duplicated record. So it says these are unique. The 1 is a duplicated record. So it doesn't come up true for all the records that have multiple observations. Does that make sense? So intuitively, I would expect this observation and this observation to be true because 1 is duplicated in this data set. But that's not exactly what it gives. It gives you, when you see a repeat, then it turns true. But not for the first one. Yes?
Can you run it on a column or a set of columns from a data frame or table?
Can you do it? I don't know if you can do it on a whole thing. You can do it on, you can run lapply.
Because we use, like a lot of times we want to find like duplicate IDs.
Yes. So you would use, for example, you could use group by on ID and then tally, and they'll tell you that the underscore ends, right? The big ends.
Okay.
All right, let's do some joining. Yes.
Yes, merging. Sometimes we may not be interested to merge all the variables into a single file. Maybe just a 2 or 3 variables.
In the using file, or
in the using file.
Yeah.
So
that's an object in R. You can just use select, right? So you can subset them, and then you can use join on that. So for example, in visits here, like we're using visits, but before you actually run this command, you can just say, visits to or visit sub equals select select the 5 columns that you care about, you want to merge into, and then you can run the merge command. Does that make sense?
Okay, so I have to do these 2 stages.
2 stages, yeah. Otherwise, you're going to add a whole bunch of those variables in there. Yeah. Really quickly, okay. So there's a merge command in R. It's not the worst, but these are just more explicit as to the type of joins you're doing: left, right, full. Cbind and rbind. Rbind is like the equivalent of appending in Stata. Cbind allows you to add columns, but again, these are good, but they are not very dangerous, but sometimes it'll just jam things onto the columns, and if they're not sorted the right way, you're not insured to have, things match up just like you would in merge. So in most respects, C-binding you don't need to do because merge will do that for you. R-binding you don't necessarily need to do either. Full joins will do that for you as well. Right? You just have to do it in a specific way. T can transpose the data. A data frame you tend not to want to do that. We're not going to cover. So I'm going to go through 1 or 2 more things and we'll jump to the lab. So I showed you this already. So is.na doesn't just work for a single vector. You can do that on an entire data set, and then you can run, so we selected A lightings, A average, boardings, and we say is.na, did it not? So now this is a matrix where things tells you is it missing or not. So this will come up true if the thing is missing, and then we can use the operations like row sums or col sums to get an indication of how many missing and all that kind of stuff. We've done that previously. A whole bunch of text here. Disregard everything except this one last function we didn't talk about, slice. So in a vector, when I said first, last, nth, slice does the same thing, but it's talking about entire rows of data. Right? So when we did like sapply, grab the first thing, grab the third thing, whatever, slice, you give it the indices that you want. 1 meaning the first, n meaning n meaning the last. That will, for example, if you're doing a group by and you want to subset on the first and last records for an ID, for example, right? This gives you, this is the first Monday, and down in the data set later is the last Monday, right? So it says go. So don't worry about all this stuff. All we're doing is arranging by date, right? And then we're grouping it by the line. Grouping it by the line, and we're grabbing the first and last. So this is the first day the banner line ran. This is the last day the banner line ran in our data set. This is the first day the green line ran. This is the last day the green line ran in our data set. So note, the green line started after the banner line. So slice mixed with indices tells you which ones you want to grab. So for example, when you say slice 1, that'll give you the first record for every observation after you do the grouping. So for example, you have multiple records per patient. You say group by patient ID and as long as the data is sorted, for example, by date or by visit, you say slice 1, it'll grab the first visit. Okay? So we'll do the lab now. Most of this stuff, most of these slides are redundant in the sense like there is a merge command, but I don't think you should necessarily use it. The join commands are much more clear as to what you're doing. All right, let's do the rest of this lab. All right. Let's join the road and crash data and let's retain only data where they overlap. So again, we're going to use inner join. If we just say no argument for by, it's going to tell us that it's joining by road. Give us a little message. Say the dimensions are merged. So there's 88 observations. If we do anti-join, right, road then crash, we see that one of the roads, US 52, is in the road data set but not in the crash data set. And we see, for example, if we do the anti-join flipping the records, we see that Interstate 275 is not, it has crashes, but we don't have any information about that road. Okay, so anti-join is kind of, again, your merge equals 1 equals 2. Inner join is merge equals 3. So join the data using full join, call the output full. How many observations are there? I don't think so there's no answer there. How many did you get? 111. What? Everybody get 111? Yes. Okay, got it. All right. Let's do a left join with road and crash. Again, the order matters here. So if we do a left join, we get 89 observations. If we did a left join but put crash first, I'm just going to say n row. Give me the number of rows. We get 110. So again, the order matters. Left is saying the first argument you give is the left thing, the second argument you give is the right thing, and pretty much left will keep all the observations in the first data set you give it. All right, manipulating all that data. Now, we don't have a lot of time, but I'm going to at least breach the subject of data visualization, because it's probably the funnest lecture. Okay. But before we move on, any last minute burning questions? Any saying like, I want to know how to do this, merging my data? No? Yes, yes, no? All right. Data visualization. We showed you so far how to make some really ugly box plots. Okay. This doesn't want to go anywhere. Okay, there we go. So we showed you some basic stuff. We're going to expand. We're going to show you some of the basic stuff still. Okay, we're reading in some data for child mortality from 1760 all the way to 2022 or something like that with projections. So pretty much, again, we've shown this data. We read it in using read CSV. First column is country. We're just reading the first column of the country. All the other columns are the year that the data was collected. Again, you might get data like this. What are we going to do first? Probably reshape it. You know what? You can go over these, but I think we're going to start with the Ggplot 2 stuff because that's the way I would suggest learning plotting in R. So Ggplot 2 has more of a standardized syntax across all the types of different plots you want to do. The base R packages are really, base R plots are really good. They're really quick, but they have different types of syntax all over the place. So Ggplot 2, it is a package written by Pat Lewickham. That was, I believe, his thesis. So it stands for the grammar of graphics, right? So that's what the GG comes from, and that means the grammar of graphics means it's more or less standardized, and you add things in a way that's supposed to be kind of theoretically intuitive. Okay, so the first function that you should concern yourself with is Ggplot. So there's a plot function in R. We've talked about that. It's a very generic function. Ggplot is in Ggplot 2. It stands for quick plot. So you specify x and y usually, not always, usually, depending on what you're trying to plot. By default, it'll plot points. You say, Ggplot, what's the x variable? What's the y variable? Which data set are you using? In this case, we're using a data set of just Sweden. One of the columns is year. The other column is the mortality data. So again, as data from 1700 all the way down here, we see, thankfully, a markedly decrease in child mortality over the last 200 years, 250 years. Okay, this is just for one single country, Sweden. So that's this data set. We specified x and y. We didn't have to put quotes around it. Again, like dplyr, we get some nice things where we don't have to do this df dollar sign, that kind of stuff. So Ggplot will return an actual object too. If you do it, if you just type it, like everything else in R, you just type something, it'll assume you want to print it. And when you print a ggplot2 object, that means plot it. Okay? So if you can assign this though to something. You can assign this to an actual object and manipulate it. So Ggplot is kind of a shorthand for this overall function called ggplot. The syntax is very different though for ggplot. So the way ggplot works, the function, and whenever I say ggplot from now on, I mean just the function, not the package. I will refer to the package as ggplot2 explicitly. So ggplot, the function, you pass in a data set, and you pass in what are called aesthetics. And you have to pass them in using this AES function. So you say the data set is this Sweden data set. It has, the year and the deaths in there. And then you say, the things I want to add to this plot, I want to say the x-axis is for year, the y-axis is for death, the deaths. G is now assigned to this object, which you can adapt and change. But all this is done is just set out a canvas. It has not plotted anything. If you print G, it's just going to be a blank plot with the word year on the x-axis, the word deaths on the y-axis. It hasn't done anything. You haven't told it what you want. Ggplot doesn't have any defaults. It doesn't assume you want to do points. So common aesthetics, X, Y, color, size, fill, and shape. So these can be mapped to variables. Okay? So if you look at the help for ggplot, it says mapping, right? And that's what you're doing with this AES function. You're mapping data to some sort of aesthetic, something you're looking at. In this case, like maybe I want things to be differently sized by the population. Maybe I want the color to represent different groups, right? Maybe I want stars or squares or circles or whatever differently by some column in my data set. That's what you're doing here. And now that you've got a ggplot object, which just makes this canvas, you add layers to it, and you add what are called geometries. The most common ones I use, geom point, adds points. Geom line, adds lines. Geom density, adds density plots. Geom histogram, right? So on and so forth. Geom smooth, adds a smoother. If you have under 1,000 points, it'll do a low S smoother and plot it there for you. If you have over 1,000 points, it'll do a generalized additive model, which essentially is a similar smoother, but not exact. It is another smoother, but it's not, estimated the same way as a low S. Geom boxplot, geom bar, geom tile. And the way you add this to the plot is by literal addition, literal add. So G, we saved that before. We said, I want to save this as G points. If I run this command, remember, when you assign something in R, it doesn't automatically think you want to print it, right? So when you say x equals 5, it doesn't print anything out. But when you say x, it prints the number 5 out, right? So this, we're saying, take this blank canvas, add points to it. Reassign it to this object called G points. And then we're going to print it out. And then it actually makes the plot, shows it up. So the reason sometimes you do things like this versus one big command that makes the plot is now you can start seeing how you can incrementally add things to a plot. Look at it, add something, look at it, add something. And sometimes you want to do both things. You want to do points or you want to do a line. That's all we changed. G was exactly the same. It set out the canvas, X and Y. And we said we just wanted a line. What if we want both? We just add lines and points. The order here matters. Here it doesn't because everything's in black. If I change the color of things, let's see, do I do that on the next slide? So here, I run the line plot and then I run a smoother over. You'll notice this gray bar here. Thankfully we're on this and not a projector because otherwise you can't see these like shadings at all. It does a smoother and it does some sort of standard error estimate. Most of the time, or a lot of the time, especially when you're using longitudinal data, that standard error estimate is not correct. The data is correlated. Right? That standard error estimate is usually assuming the data is independent. So if you say SE equals false, as an argument within here, you can tell it not to print the standard error estimate. Okay, let me go back. I want to show you something specific to say like. Okay.
Is there an easy way you can add the shadow so it's a confidence interval?
You have to create that yourself, usually. I believe, at least in Ggplot, right? Not like there are probably additional packages that I believe will do that. May do that for you. Okay, so here's points. Right, we said add lines and points. Within each one of these, I can say color, not red, is red. It's red. So again, I put the lines first, then the points on top of it. And you see the line is masked out. If I switch up the order, right? Different display because what's plotted first and then what's plotted on top of it. There are other things, there are other aesthetics that you can change. For example, you want an opaque line, you can do that. You can change the alpha level, the opacity. All right. And you can start with Ggplot. I tend to use Ggplot. Because I just say, I want to set my X and my Y, and I'm going to start adding things to it. Oh, and lastly, I wanted to show you SE equals false. It'll just do the smoother. It'll tell you what smoother it is, and then it'll just give you the line. But again, even for this data, right? It's correlated data. So to do a confidence interval, you have to specify the model correctly, right? Or how you're estimating that confidence interval correctly. Where are we at? Okay. So Ggplot 2, you pass in a data set, you tell it pretty much what aesthetics you want to do. For example, in a histogram, you just need an X variable. You don't need an X and a Y. You just pass an X and say like geom histogram, right? So let's just do that. Let's just say geom histogram. Let's say ggplot AES X is deaths. We make really non-morbid column names in this class. Deaths. We have to specify the data. Swede long. Geom histogram. Right? I don't like histograms. Let's do densities. Density. Okay? So what I'm saying is, hopefully, it should be relatively clear to see that if you want to do a type, it almost undoubtedly is a type of plot that's almost undoubtedly implemented in Ggplot Ggplot 2, and the syntax is very simple. You just change the geometry thing you're adding to it, the layer you're adding on top of it. Whereas, like, for example, in base R, it could be totally different. Boxplot has formula syntax, barplot is something different. Stata, some things you can do graph 2 ways, and then graph, you can do certain groupings and all that fun stuff, and it doesn't work for other types of plots. So here, we are taking the original data, all the data of all the deaths, and putting in these 4 countries, which I don't know why we chose those. We actually chose them at random. U.S., well, maybe not. Maybe that's a lie. U.S., U.K., Sweden, Afghanistan, and Rwanda. Right, so I just subset my data, standard filtering operations we did with dplyr, and now I say Ggplot sub X is year, Y is Z, and I want it colored by country. And then I want lines, so I say plot G. So now, because I don't assign it to anything, it automatically prints. When it prints, it plots G plus G on line. Now it does a line, gives us a little legend. We can move that legend around, put it wherever we want. It does default coloring. We can change those colors to be whatever we want. And we'll get more into that tomorrow. But hopefully, and then we can change the themes. I don't know, what is it called in Stata? What's S2 mono? Do you know what I'm talking about? Or economic. There's like overall schemes of how plots are supposed to render.
Like the color scheme.
Color schemes, yeah. So in Ggplot 2, they're called themes. So there are different themes. Right now, you see it has gray backgrounds with white lines. It's got grids. You can turn that stuff off. You can change it to be a white and black background kind of thing. Just like I can pretty much spot a Stata plot from a mile away, you can spot a default Ggplot a mile away. So what? So a couple things. Rip this figure apart. What's bad about it? So it's great. You'd put this in your paper tomorrow, today. There's no title. Okay. Colors. Axes to me aren't that informative. Everything. I assume everyone's blind. My axis sizes are huge. Right. That's too small. I personally don't like legends outside of a plot. There's a bunch of white space here. Just put it in here. That's what I tend to do. It would bother the heck out of me as a reviewer that country isn't capitalized, just small stuff like that. It would. Also note, I think Stata does the little flip of the axes, right? Like one would be sideways and stuff like that. I personally don't like that because I don't read like this. So different defaults. Yeah. So we can change all those aspects. Maybe you want the ticks to be at different spots. And we'll get to that. Or at least some of that. So lastly, if we're like, I don't really need that legend. So in Ggplot 2, they're called guides. And you'd say guides, whatever you mapped. So remember, before we mapped country into color. You say guides, that whatever you map into equals false, and it removes that. All right, I'm going to end there, and I'm going to show you one really cool thing that we're not going to get to, but one thing you can do in R. Okay, so GG. Oh, no. Where is it? Okay. There. So there are packages in R. One of them is called Plotly. You can do stuff like this, where you say Ggplotly, and it gives you an interactive graphic. That's kind of crappy. Let's see if we can just make this bigger. Come on, it doesn't like to resize. You'd say, I didn't really like Afghanistan. Sweden, get rid of that one. Put it back on. Play with it, stuff like that. So you created everything in Ggplot, but interactivity can come from these other packages where you highlight and you're like, That's the deaths. It's like, get rid of the UK. I only really want to look at these two countries. I only really care about data after 2000, so get rid of that. I'll just zoom in on here. Let's put Afghanistan and stuff back in there, so we can take a look at that. So you can do interactive exploration of your data, which, if anyone's like, why choose R? I can guarantee try to do this in Stata or SAS, and I don't know. I don't even know how you'd start. So,
Is there a big difference between ggplot and ggplot 2?
There is no ggplot package really anymore at all. It was just, he put out the first version and rewrote the entire thing from scratch and was like the old thing just wasn't implemented the right way. So, yeah. And Hadley said if he could go back after the pipe operator was kind of invented for R, he wouldn't use plus anymore. But since it's already been such a well-established package, that's why, although dplyr uses pipes, ggplot 2 still uses plus, right? You're still adding, right? And that's still kind of the philosophy. I forget and it's sad, the main author of the book called The Grammar of Graphics, because he was the one who really inspired that. Adding is actually the way we think about building plots, so that's why addition makes sense.
When you have you add like geom lines,
Mhm.
can you store those as data objects and then just go G plus my line plus my guides? The reason being that you could like define them all at the top and then for multiple plots.
So, sorry, what do you mean?
See where it says guides color equals false?
Yep.
Could you just have up the top Tim's guides equals guides and then here just
Yep, you could just say like no guide. Guides color equals false.
and then in that next line
Like fill equals false. All right, and just say like.
excellent.
So in the notes, I have one that's for a transparent legend.
Because then you can define it. Like if you're doing 10 plots, you don't have to write it out 10 times.
Yep, exactly. And that's the beauty of ggplot versus base R graphics, because base R graphics is like plot, and like this is an object that you can start adding to and manipulate. And like sometimes, and we'll show you how. So we'll show you how to open a device, and let's say all my plots, and in here you just have to say G plus geom point, G plus geom line. And you can have the exact same plot just with different kind of things on there where you don't have to like copy and paste the same code over and over again. That's why I think it's a really good thing. And then now, theoretically, you can save this out as an RDA. It's just an R object. Manipulate that. And then later, you can do it where you've created an entire plot with one data set, and then you can say like new data, and then you can actually take that template and throw in a new data set, and it will do that plot from the get-go. Like in the sense, like if you had a new data set, like let's say you created a data set all on this data, and you have another data set in memory that has those columns that you specified, but you don't have to want to recreate everything again. You just say throw the new data into this plot with all the specifications, and it'll make it for that data set. But it still has to be like if you had a column called year and deaths, and you still need to have that. Yep. But we're going to get into that more in detail tomorrow, some more lab stuff. So Viz tomorrow, then statistics, and that's it. All right. So 1 o'clock tomorrow in this room again. So we do have it for tomorrow as well. And again, QuickR, or I think it's statmethods.net, has really good tutorials on like making exact plots that you want, especially stuff with like error bars, that kind of stuff.